Hello everyone, welcome back to our lecture on addressing modes. So in our first lecture we have seen what is addressing modes, why it is required, and we had also looked at some of the addressing modes, and we had looked at the implied mode, immediate mode, register indirect mode, auto increment and auto decrement mode. So now what we are going to see is we are going to continue with this, and the first addressing mode we are going to look at is the direct addressing mode. So the direct addressing mode, as the name again tells you, here the address field of the instruction contains the memory address of the operand. So if I have, say, add 1000, okay, 2000, then 1000 and 2000 is the effective address. Effective address is 1000 and 2000. So that means if you go to memory location 1000, you will get your first operand, and if you go to address 2000, you will get your second operand. So that is direct. So whatever is given in the address field of the instruction is the memory location where your operand is present. The next is your indirect mode. So the indirect mode is like a pointer. Just like in a pointer points to a memory location, or it holds the address of a pointer, holds the address of another memory location. So in register indirect, if I have, say, add 1000, 2000, then 1000 and 2000 are not the effective address. So I'll go to address 1000, or I'll go to address 2000. 1000 and 2000 will not hold the operands. Instead, they will hold the operands where they will hold the address where the operand is stored. So if, say, 1000 holds 1050, then I will go to address 1050 to get my first operand, and say 2000 memory location contains 2004. So I'll go to address 2004 to get my second operand. So this is indirect. So what is the effective address? The effective address is, I take this address, whatever is there in the address field, then I go to that memory location, I get the value what is stored here, then I use this to go to this memory location, and then what I get here is my operand. So that is why I have to go through two levels. So first I will go to, say, 2000, take out the value, use this to go to the next memory location 2004, and then I will get my operand. So our effective addresses in this case is 1050 and 2004. So this is your indirect addressing mode. So you can draw the parallels between direct mode and register mode. Okay, in register mode, instead of we have the address of a register here and the address of a register here, and these two will hold the operand, contains the operands. In register indirect, here instead of a memory location you have a register address, and that register address holds the address of the operand. Whereas in case of direct and indirect, all are memory locations, there are no registers involved. Now the next addressing mode is our relative addressing mode. Now this is slightly different from the rest. It is different in the sense that here the address of the program counter, if you can recall the program counter that we have seen, it's a special purpose register which always holds the address of the next instruction to be executed. So the address of the program counter is added to the address field to get the address of the operand. So now suppose I have add 20. Okay, so this is my address field. All right, and the program counter holds some value, say 2000. Okay, so what we will do, the effective address I will calculate as contents of program counter, which is 2000, plus contents of the address field, which is 20, so 2020 is our effective address. So I'll go to memory, address 2020, so I will get some value which is here. So this is your relative mode. So relative mode is contents of the program counter plus contents of the address field. So usually this relative address mode is used in case of branch type instructions, like when you have to jump from one location to another location, okay? And also lesser number of bits is used to represent the relative address as compared to the full memory address. Like if you see here we have put 20, all right? 20 will take much lesser number of bits to represent, instead of using 2020, which will need more number of bits to represent. If you just think of the digits, for 20 I need 2 digits, for the memory location 2020 I need 4 digits. So think of it as bits, and then you will need lesser number of bits if you use relative. Instead of storing directly the address, 20 will take lesser number of bits. So that is the only advantage of this type of addressing mode. And also, of course, as I mentioned, it is used in branch type of instructions. The next is our base register addressing mode. Base register. So here I'm going to use a special register known as the base register. So the base register will hold a value. Say it holds a value 1000. Okay. Then I have some instruction. Say I have add, and then I have in the address field I have a value 20. Okay. So what do we do now? The effective address for this instruction would be contents of the base register, which is 1000, plus contents of the memory of the address field of the instruction. So you see the process exactly same like your relative. In the relative we are using the program counter. Here we are using a base register. So you think of this to be something like this. You have an array. Okay, you have an array. Starting address is say 1000. Okay, it's a large array. Many number of fields are there. Okay, so the base address of this array, you store it in the base register. And when you're using the operation, or you're using an instruction, instead of using an address here, you just give the index. Okay, so you use, say this is index 0, this is index 1, this is index 2, like that. So since we use 20, so that means from the base 1000, go to the item 20 items from address 1000. So add this, so you go to, so this element of the array is stored in location 1020. So the base is stored in the base register and the index is there in the address field. Now the next addressing mode is just the reverse of this. So here now this is known as index register addressing mode, or not index register, indexed addressing mode rather. Let me just remove this. It's not index register, indexed addressing mode. So here now I have an index register. So in the index register, as the name suggests, instead of storing the base address, I'm going to store the index. And the address field will hold the base address. So now effective address would be again same, this 1000 plus whatever is there in the index register, 20. So I get 1020. So if you look at both of these, they are effectively the same. The process is the same. You just add the contents of this special purpose register with the value that is there in the address field. Okay, so here also you do the same. In fact, even in relative also you do the same. So only difference is in the use. When do you use? So relative addressing mode we use when we have to do some branch operation or jump operation. Okay, base register when we want to iterate through the items of an array, okay? And index also, you're doing the same thing basically. You're looping through the items of the array, but what is not changing? Your instruction is not changing. Instead, you can keep on changing the contents of your index register. So you can start from 0, then it is accessing the first element of the array, then you make this to 1, 2, 3, and can go on like this. So you, in this case, you manipulate the index register instead of changing the instruction. Whereas in case of base register, the base register remains fixed, whereas you keep on changing the address value that is there in the address field. So the difference is only in the use. So we have come to the end of these addressing modes. So you have seen that in all these cases you can find out the effective address, which is the actual address of the operands. Actual address of the operands. So using the different addressing modes, you can find this out. Okay, and one more thing to be noted here is that if your instruction has got 2 address fields, 2 addresses, then for each of these you will have 1 addressing mode. So two address fields means 2 fields for addressing mode. 3 address fields, you have 3 addressing modes, 1 for each address. So that is all about your addressing modes. So I hope you have understood this, and then we will discuss a problem in the next video.